Okay, dear student. Now, today let's see that the topic of ideal and non-ideal solution. Ideal and non-ideal solution. Okay. So before this topic, we already studied that the Rowler's law. Actually, the Rowler's law that obeying the ideal solution. Okay. So first of all, the ideal solution, that is it obeying the Rowler's law. Rowler's law. Okay. Okay. In ideal solution is obeying the Raoult's law at all temperature and the concentration. Whenever that solution that obeying the Raoult's law at all temperature and concentration, for that solution or ideal solution. Here, the change in enthalpy that is equal to 0. So enthalpy is equal to 0 means here no heat are exchanged. No heat are exchanged. Okay. No heat are exchanged. Whether they have absorbed or not at all possible. It's absorption or emission. Okay. So no heat is exchanged means the change in volume is not equal. Change in volume is equal to 0. Okay. So there is a volume also is equal to constant. Now the change in free energy is equal to negative and the change in entropy that is equal to positive, because the entropy or increases with increase of randomness. Okay, whenever the randomness or increases, the entropy also increases. For that reason, the entropy order for gas is greater than liquid is greater than for solid. Okay, so the gases has a more randomness. For that reason, their entropy are greater. In that entropy concept, for using that ideal solution, now the solution it containing a beaker. Whenever applying the pressure, okay, so or whenever applying the thermal energy or temperature, here they have creating the pressure, there is a vapor pressure. So it's already studied for this content, because of the temperature is directly proportional of vapor pressure, and also there is a external pressure is equal to external pressure or inversely proportional of the vapor pressure. For like that we already studied. Okay, so first of all, the solution is containing the two component. The solution it containing the two component. One is a solute, another one is a solvent. Okay, so for this solute and solvent, if you assume this A and this is a B, like that we assume. Okay, so the next the solution containing the solute and solvent, for this A and another one molecule of A. Okay, so both A and A attraction, or there is a B and B attraction, that is equal to for AB attraction. Okay, that's for the nothing but the attraction between that one molecule to another molecule. So these three kind or a similar attraction one to each other. For that reason, the solution it is a cannot be expanded. That is a delta V is not expanded, and the change in enthalpy also is not changed. Okay, so for that kind of the values, or the kind of the delta V and delta H are presented solution, or called there's a ideal solution. Okay, now we go to the graphical representation. There is a vapor pressure and there is a mole fraction. Okay, vapor pressure and mole fraction. First of all, here there is a mole fraction of A as a maximum and the mole fraction of B is equal to 0. In this case, the mole fraction of B as a maximum, mole fraction of A is equal to constant. According to Henry's law, the partial pressure or pressure is directly proportional of the mole fraction. Okay, for that reason, here the mole fraction of A as a greater, so the partial pressure of A as greater here. The mole fraction of XA is left to right as a decreases and finally getting a 0. So for that partial pressure are gradually decreases. And similarly, the mole fraction of B as left to right increases. So for that partial pressure are gradually increases. Okay. Okay. So these two as nothing but the total pressure. Total pressure is equal to partial pressure of A plus partial pressure of B. Okay. So now the partial pressure of A is nothing but the P naught of A and X of A, and this is a P naught of B X of B. Okay. So now see this graph here. No volume is expanded or decreases. And similarly the change in enthalpy also is not extended. But in the case of non-ideal solution, okay, there's a non-ideal solution. So non-ideal solution, the solute and solute or solvent or solute to solvent attraction are not equal. Here there is a is not equal to A attraction, or is right like that, A attraction not equal to B attraction, is not equal to AB attraction. So those not equal to means that is a non-ideal solution. In generally, that non-ideal solution classified in two types. Okay, one is a positive deviation and another one is a negative deviation. In the case of positive deviation, here the delta V is equal to positive. Okay, the delta V is change in volume is a increases. When the change in volume increases, when apply the surrounding to system the heat energy, or the system is gain the heat energy in the enthalpy from the surrounding, that is nothing but for endothermic. Okay, so the delta H is equal to positive. Okay, and similarly the negative deviation, here the change in volume is equal to negative and the change in enthalpy is equal to negative. Okay, so the change in enthalpy is equal to negative means that is nothing but for exothermic reaction. Exothermic we well familiar, because the exothermic means the heat energy is lost out from the system to surrounding. Okay, so that is for that exothermic reaction. We go to that graph in the positive deviation as well as a negative deviation. Okay, so this graph here, there is a P of A and X of A is equal to maximum and X of B is equal to 0, and similarly here there is X of B is equal to maximum, X of A is equal to 0. There is a partial pressure of B, that is nothing but for ideal. Ideal solution means there is a linear relation in that above the direction or increasing that. Okay, see this. This is the positive deviation, and the downward direction means that is a negative deviation. Okay, so how they asking the NEET and JEE question or problems, they have asking the examples. Benzene plus toluene, what kind of solution? Okay, benzene plus, that is a toluene, that is for ideal solution. Ideal solution. Okay, I will show that all examples for your useful reference. Okay, they have mostly theoretical question asking for that JE and NEET level problems. Okay, thank you. If you like this video, you can subscribe and share your friends. Okay, thank you to all.